We are picking back up in lesson 3.3 with implicit differentiation. Okay. Now, we are ready for number 6, and we have some options, right? But if you recall, these equations are equations not solved for y. When we take the derivatives, x values, we just take the derivatives normally. Y values, we take the derivative and then tag on a dy dx, the derivative of y. Now, we have options here. I'm trying to decide. I don't know that one's easier than the other, honestly. Not really. What do you want to do?
I see product.
Okay. Now, so keep in mind, this is the natural log of xy, yes? So, before you go product rule, the outside is a natural log. How do we do the derivative of natural log of something? 1 over something, right? So we're going to start with 1 over xy. But then it's times the derivative of something. And so now we're doing times the derivative of xy. And this is where, you guys already said the good word, you said product rule. So the derivative of xy is product rule. So the derivative of x is 1, keep the y. Plus, this time I'm going to keep the x. The derivative of y is 1 dy dx. Okay. And then equals the derivative of sine of x is cosine of x. And we could say times the derivative of x, but the derivative of x is 1, so we don't need that. Okay. We need dy dx to be isolated. I would suggest, or shall I ask, what are you guys doing? Or do we know?
Distribute the 1 over xy.
Yeah, I would distribute that and see what we end up with. So when you do 1 over xy times y, what happens in the first spot? Y over xy, but what could cancel? So it could just become 1 over x. Plus, now distribute 1 over xy to x dy dx.
dy over xy dx.
Yeah, I'm going to write it as 1 over y dy dx, though.
Extra x too, right?
Say what?
The extra x too.
Well, okay.
Because it's x dy dx, not
But
dx.
the x canceled with this x.
Oh.
1 over xy times x. Basically, I did 1 over xy times x. X cancels. I'm left with 1 over y. And then I've got the dy dx left. Okay? Equals cosine x. Okay.
We just subtract and divide.
I'll give you the subtract. I'm going to do something other than divide when we get there. But so if we subtract the 1 over x, that's going to leave me with 1 over y dy dx equals cosine x minus 1 over x. And then, yes, you could divide by 1 over y, but then you have what? Yeah, so we don't want to be doing fractions divided by fractions. So multiply by y is going to cancel your 1 over y. And on the other side, I'm going to write it as y times the quantity cosine x minus 1 over x. I don't think, yeah. You could distribute it. I didn't. It would be right both ways. Guess I was in a boxing mood yesterday. I was boxing. Now, real quick before we go to the next one, I said there were two options here, yes? You guys saw the product rule, we jumped right in, the derivative of natural log of something, and then we had to do the derivative of something, which gave us the product rule. Now, here, natural log of xy. What about these log rules? How else could natural log of xy be written? If there's multiplication inside of a log, it can be broken up and written as 2 logs being added. Remember that log rule? We talked about it a little bit previously. Okay? That natural log of xy can be rewritten as natural log of x plus natural log of y. The advantage here is the derivative is a little bit easier. You don't have to do that product rule messiness. Because the derivative of natural log of x is 1 over x. The derivative of natural log of y, 1 over y times dy dx. And the derivative of sine of x is cosine of x. And then that puts you that same point right there. Okay? So, what'd you say?
Just have the same method every time.
And then that's fine. Then don't worry about that. It's just you need to remember that log rules will sometimes clean things up and make things a little bit better when we're doing derivatives and whatnot. Okay? So it's just something to keep in the back of the mind. Okay, we're ready for 7? 7, we have this beautiful rotated ellipse here. Okay, we studied ellipses back in pre-calc, back like last January. And the x squared, y squared is what makes it an ellipse. The xy term is what makes it a rotated ellipse. So it's no longer just a horizontal or a vertical. Now, they ask us to find the equation of the tangent line at the point -1, 2. And then eventually we'll do equation of the normal line. Well, to do an equation of the tangent line, what are we going to have? Derivative. So what do we have to do? Implicit differentiation. Okay, so we need to find that derivative so we can find the slope. So, what do you got going?
Yeah.
Okay.
Minus, and that just being like minus y plus x dy dx or something.
Okay. Yes, we have to watch our signs here. Okay, we can do this one of two ways.
The quantity of it.
Yeah. So you can think of it as minus, and then we're doing a product rule here. The derivative of x is 1, keep the y, plus, and then if we keep the x, the derivative of y is 1 dy dx, and your quantity. Or, yes, I agree with Logan that the other option would be to distribute that and have 2 negatives. Both are good. Plus,
2 dy dx.
derivative of 2 what? Derivative of y squared is 2y, and the derivative of y is dy dx. Take the derivative normally, and then tag on the dy dx. And then derivative of 7 is 0. Okay? I don't know, how crazy talented are we? Can I do like a bazillion steps at once? Can I separate stuff to opposite sides and factor out the dy dx?
No.
You being a serious no or a joking no? Okay. So, how about I maneuver stuff? How about we keep the dy dx's here, which that is going to be a negative x dy dx when you distribute that, and a plus 2y dy dx. I'm going to keep those pieces on the left. I'm going to subtract over 2x, and it's a minus y. So I'm going to add the y over. Does that work? Now, are you factoring and dividing at the same time here, or are you just factoring?
What?
So now we have two dy dx terms, so we want to factor out the dy dx. And once you factor out the dy dx, you're also going to divide by the negative x plus 2y. So this becomes negative 2x plus y divided by negative x plus 2y. Let me pause and ask, are we okay with that?
Mm-hmm.
Okay. Now, what do I need to do?
So I know it becomes positive. There's two negatives.
Yeah. Well,
Well, you can't do that though because we've got these, they're added and subtracted to other terms. So we can't do that. If we're writing an equation of the tangent line at a certain point, what's our next step?
Oh, just write the equation.
yeah.
Okay, what's my slope?
That.
It's that evaluated at the point negative 1, 2. So my next step is I have to find what is dy dx evaluated at the ordered pair negative 1, 2. That's what's going to find me my slope.
I got 4/5.
I'm going to side with the 4/5.
Yeah.
Okay, so what is that 4/5? That is my slope. So we have a slope. We have a point. I need equation of the tangent line, please.
Y equals 4/5. Parentheses x plus 1 and parentheses plus 2.
Okay? Okay. B. Equation of the normal line.
Negative 5/4 parentheses x plus 1 and parentheses plus 2.
Okay. So my given slope up above was 4/5. Do you guys remember normal line that I take it?
Just the opposite, so negative.
Yeah. It is the perpendicular line, and so the perpendicular slope is indeed the opposite reciprocal. So negative 5/4. So yes, y equals negative 5/4 times x plus 1 plus 2. Okay?
Dare I say that was more simple than yesterday?
You had a night for it to sink in, maybe?
Maybe.
I don't know. There are days you guys come back and you're like, oh, this is easy peasy now. And then there's one day last week, I thought everything was going really well the first day. You guys seemed really, and then the second day we came back and it fell apart. So,
Yeah.
I don't know. Hopefully, I mean, this equation of the tangent line stuff, it's not going away. They ask you to find an equation of the tangent line, you're finding a slope using the derivative. You have a point, okay? Or you're finding a point. Okay. Higher order derivatives. So, this is implicit differentiation when we want more than just a derivative. So in finding higher order derivatives using implicit differentiation, be sure to solve for dy dx before finding the second derivative or higher. The subsequent derivatives will have a dy dx term in them, and for each of these terms you can make a substitution to be able to put your final derivative in terms of x and y.
So it's basically just do what we've been doing and then find the second derivative of it, right?
Kind of. do what you've been doing, find the second derivative, and then you'll have to also plug that first derivative into the second derivative a little bit.
Why is it d2y dx2?
Because that's the notation for a second derivative.
Okay, so you don't do anything.
No, that is standard notation for when they write the higher order derivatives.
Gotcha.
You want honesty? I'm not sure why it's d2y and then dx2. I don't know the different placement. I'm sure there's a reason, but I honestly don't know it. I just know that's what you do. Okay? Okay, so let's start by finding our first derivative.
Sine y equals 1. Negative sine y.
You're missing a detail.
ny dy dx.
Y.
Okay,
Negative sine y times dy dx equals 1.
yes.
Then
The derivative of cosine of
dx
something, cosine of y is going to be negative sine of y times dy dx.
equals 1 over negative sine.
So now if we solve this, and there's a couple of different ways we can show this, but dy dx, if you divide that over, is negative 1, or negative of 1 over sine y, if you will. There's a negative somewhere there. How else could I write 1 over sine y?
Negative cosecant y.
The reciprocal of sine is cosecant. And so I actually have this written in my notes as dy dx being negative cosecant y.
Negative cosecant y is
Okay.
cosecant y cotangent y.
Or are you working on the next derivative?
Yeah.
Okay. So there's my first derivative, yes? So, like Logan said earlier, we basically do what we did there. And then we're going to continue, and we're going to try the second derivative. So now for the second derivative,
I believe is cosecant y cotangent y.
so the derivative of dy dx is going to be that d squared y dx squared. On the right, the derivative of negative cosecant of y. So, I don't know how you guys do it, but my brain says, okay, I need the negative out of there for a moment. What's a derivative of cosecant of something?
Negative cosecant.
Right, it would normally be negative cosecant cotangent. Since we're taking the derivative of a negative, that flips this to become a positive. So it is going to indeed be cosecant y, cotangent y, dy dx. Okay. Now, effectively, we've taken the second derivative, but we're not going to leave it like this. You don't leave an answer.
So what, we plug in that negative cosecant y for dy dx?
So now, d squared y over dx squared is cosecant y, cotangent y, times negative cosecant y.
Do you distribute?
Don't think distribute. It's just multiply. You distribute if there'd be a plus sign between cosecant and cotangent.
So just negative cosecant squared y cotangent y?
Okay. Definitely move the negative out front. Cosecant times cosecant is cosecant squared y times the cotangent y. I was debating. I have another version of the answer in my notes. But I don't think I'm just debating if I want to go there. I wish I remembered if she went there in homework. Yeah, I'm not going to go there. Okay. You guys ready for 9? Find the points at which x squared plus xy plus y squared equals 27 has either a horizontal or vertical tangent line.
Find the slope is 0.
Find where the slope is 0 or where the slope
Does not exist.
Now, before where I can find where the slope is 0 or the slope doesn't exist, I need to find the formula for slope.
Yep.
Which means I need to find dy dx, right?
Yep.
Okay, so let's start there.
2x plus, I already achieved it.
Have that many numbers, yeah.
It's what?
You guys are catching on. You see this one a lot.
Plus y plus x dy dx
Yep.
plus 2y dy dx equals 0.
Good. And you are exactly right. You do just, you use that one so much when you get into doing this that, yeah.
I can't. We just did this.
Well, I'm going to go ahead and factor out my dy dx terms, dy dx,
It ends up,
and I have x plus 2y.
ends up becoming negative 2x plus 1.
Whoa, we don't have a negative in this one? Oh, I see, once you,
Oh wait, no, it's gonna be a little different. 'cause
yeah,
we might-
the sign, we didn't have a minus sign there, so. Okay, what I did is I factored out my dy dx of those terms, and I moved the other terms to the right. And now I'm going to divide. Mine is listed as negative 2x minus y over x plus 2y. Okay.
Again.
Now, what do we know? Let's talk horizontal here. A horizontal tangent line has what?
0.
Slope of 0, which means dy dx needs to equal 0. How does a fraction equal 0?
You said equals 0.
Well, but just in general, think, yes, we can set equal,
Negative 0.
Not- when the numerator is 0.
Or, oh yeah.
Yeah, when it's
Because
denominator.
for vertical, we're gonna set the denominator. equal.
Yes. So what I'm saying is I'm not going to actually set the whole fraction equal to 0 because to equal 0, it's the numerator has to be 0, right?
Yeah.
So I'm just going to set negative 2x minus y equals 0.
Then what? Solve for y.
Solve for y, yes.
Gonna become negative 2x. Y equals negative 2x.
Y equals negative 2x eventually.
Yeah.
Okay.
Yeah.
Then find the points.
Okay. So, and we'll come back and we'll wait and do vertical here in a moment, I guess. Okay, so right there, we know that horizontal tangent lines are going to happen when y equals negative 2x. What we're going to do is we're going to grab our original equation here. Every place we see a y, we can replace it with negative 2x. And then we're going to have an equation that we can solve that just has x's in it. And if I recall, it works out, yeah, it works out okay. So I'm going to take x squared plus x times, what am I putting in for y? Negative 2x plus y squared. Again, what am I putting in for y? Negative 2x. Okay, clean this up. X squared. What's x times negative 2x?
Negative 2x squared.
Negative 2x squared. Plus, what is the quantity negative 2x when you square it?
4x squared.
4x squared. Good.
So you get, oh, okay, 3x squared equals 27.
Okay. 3x squared equals 27.
So,
I would not square root both sides unless you've already done the other step.
Yeah.
Did you divide by 3? Okay.
as a horizontal tangent line at x equals plus or minus 3.
Okay. Good. Do remember the square root of 9 is not just 3. We're in an equation setting it's at plus or minus 3. So that means they're going to be horizontal tangent line at, now here's the deal. Officially, it says to find the points. Are points just x values? No. Points are ordered pairs. So 3 comma something and negative 3 comma something. Now, you want to do this the easy way or the hard way?
Well, you would think the easy way.
Which one has exceptions?
Okay. Well, okay, here's the deal. Normally, if you know x is 3, what do you normally think about doing to find y?
Plug it back in.
Plug it back into this equation. Can you do that? Yes.
Plus negative 2.
Oh, I forgot about that one. We do have that one, don't we? I forgot about, I'm up here. I forgot we have y equals negative 2x. Can we plug it in right there? Yeah. So that's a third option. I was also going to say they gave us a graph. I normally wouldn't expect you to have a graph, but could we use horizontal tangent line? Think about it. It's at 3 what?
3.
3, what's that y value? 3, negative 6. And,
Well, there's one up top.
right, that's going to be at negative 3, 6.
No, but there's a 3 value up top. If you go up on the x-axis from 3,
But that's not a horizontal tangent line. Horizontal tangent line, right? Where the tangent line is going to have a slope of 0. I see. So you're looking here, but here's my problem there. Am I going to do a horizontal tangent line?
no.
No.
So.
And now,
6.
are you guys working on the next part?
So right now.
Oh, okay. I'm ready to talk about vertical tangent lines whenever you are. A vertical tangent line is going to have a slope that does not exist. When does a fraction not exist? When your denominator is 0. So x plus 2y equals 0. I again solved it for y. I don't know that you couldn't solve it for x and just plug that in instead and find your y values instead. You'd just be doing the opposite, but so I end up with y equals
X over 2.
negative. I wrote mine as negative 1/2 x. Negative x over 2 is great too. And plug it in. So it's x squared plus x times that y value plus the y value squared equals 27. And that y value I'm plugging in, I wrote it as negative 1/2 x. Logan wrote it as negative x over 2. Either or. x squared, x times negative 1/2 x is going to be minus 1/2 x squared plus negative 1/2 x quantity squared.
It's going to be x squared over 4.
I wrote it as 1/4 x squared, so yes. Now, 1 minus 1/2 plus 1/4. That's where I'm at. So I'm at 3/4 x squared.
3x squared over 4. Yep.
I would,
What is that? 4 is 100.
yeah. How about 27 divided by 3 times 4? As in,
Well, I also had 3x squared over 4.
yeah, but it's still the same idea. Okay, so I just multiplied by the reciprocal, multiplied over 4/3. I'm old-fashioned and like to cross-cancel. You were going to do it in steps, Logan. You just had to multiply by 4 in the process, so, and then divide by 3.
X equals plus minus 6. And then
So vertical tangent line, we know, are happening at 6 comma something and
6 comma negative 3 and negative 6 comma 3. Let's look at 3 and 6.
that's the way it is. So I don't know exactly how Logan did that, but you can look at the graph here and see that it's going to be at a 6 negative 3. And over here, see that it's going to be at 6 negative 6 positive 3. Okay, using that y equals negative 1/2 x would work great as well. Okay. That's a big one. The pieces are all there, though. I mean, it's just being able to figure out what to do with it. Okay, questions? Okay. We technically have a few minutes of work time.